Good morning. My name is James Little from Mass Spec Interpretation Services. Today I would like to present a video on the identification of surfactants by electrospray liquid chromatography mass spectrometry. I did the original work in 2006 and presented it as a course at PittCon. It was very useful to a lot of people in identification of surfactants, which can be very complex mixtures. And these mixtures are also very important to analytical chemists, organic chemists, and particularly formulation chemists. Our approach used at Eastman involved the samples are separated by HPLC, they're analyzed by LCMS, MSMS tandem spectra obtained, and then they're searched in the Nist commercial and in our user MSMS Nist library. Monomeric surfactants data is used to search custom Excel spreadsheets or SciFinder or ChemSpider. And PEG type surfactants are very complex, and we use an approach called the residual molecular weight to identify them. On my website, you'll find a link to the total course, the class presentation for PittCon, detailed experimental and discussion, essentially a technical report about the topic, and then finally the spreadsheet of monomers based by residual molecular weight and other variables. Anything that's shown in green is an improvement that significantly changed the application since 2006. The application has really not changed, but the tools that have been developed since that time due to changes in software and hardware have made it even a more powerful approach for this application. The samples are first separated by reverse phase HPLC. You'll find the link on my webpage that talks about it, but it's pretty much common approach. But we do add post-column ammonium acetate and methanol that allows you to go toward 100% organic and still get a good sensitivity for ionization via electrospray. We do both positive and negative ion electrospray and get accurate mass and MSMS of the compounds. And what's changed since 2006 is the hardware and software for doing accurate mass within our laboratory at Eastman, which makes it a much more powerful approach. The Nist commercial and user MSMS libraries are searched with the Nist search. We search their tandem spectra using the Nist 23 software and associated libraries. We also use the Eastman MSMS Nist library, which is very useful, so I highly suggest you create one for yourself, but it is proprietary. There's been a large increase in the entries from 2005 to 2023, 2024 actually, but you can see them down below that it's gone from 1,000 up to 51,000 and from 5,000 associated spectra to 2.4 million. And the vendors can use this Nist search within their software, and this is made easily done by Nist sharing this note here that tells them how to do it. And Agilent does a very good job. Thermo does a very good job. Agilent, even with their open lab, does a good job. But the main thing has been the ability to search more and more entries of very high quality database and create your own libraries. Another thing is a novel Nist hybrid search, which infers structures not found in the standard entity search. So this is something you'll find very valuable, and I can't go into detail because it's a little complex, but you need to learn about this because it really extends the capability of your user and commercial MSMS libraries. Monomeric surfactants data is used to search custom Excel spreadsheets, one within Eastman, SciFinder, and ChemSpider. The SciFinder is used to search things with molecular formula. So you determine the molecular formula from the accurate mass and the very good isotopic fidelity type data that you can get, hopefully to limit it to one molecular formula or maybe two. And then you limit the search by the number of references that are associated. So the ones that have the most high number of references are the most interesting, or keywords such as surfactant or even partial structure can be useful. ChemSpider allows you to search by molecular formula like SciFinder, but it allows you to do the monoisotopic accurate mass plus or minus whatever error you think is appropriate for your instrument, and then sort by the number of references or commercial sources, etc., that show up within ChemSpider to bring the most interesting ones to the top for consideration. So we have the Excel spreadsheet and also have links that show how to use SciFinder to do anything, but you could do it for monomeric surfactants and the same thing for ChemSpider on my webpage. So the last topic is the residual molecular weight index determined for polyethylene glycol surfactants. It's a convenient way to reduce a polymeric ethylene oxide surfactant series to one index number. This index number has a value of between 0 and 43. It can be accurate mass if you have that. It'll narrow down the possibilities in our table. All these are listed in our table, or it could just be a nominal one. And then, as I said, the values are searched in our Excel Eastman spreadsheet that I put together of the different types of surfactants. This is discussed in detail in the class presentation, 24 through 36 pages. Detailed experimental and discussion is discussed in many places, and here you'll just have to search by keyword for residual molecular weight to find the different topics. And finally, to make the process work, you need to use the Excel spreadsheet. Here's just a rough idea how it works. It goes in detail in the documentation, but it's essentially doing long division to get a residual part that's used to serve. So you first have to take your ion that you see. You can pick any ion in the series. It doesn't matter. They all give the same residual molecular weight. And you have to correct for the ion added. So if it has an ammonium addict, you have to subtract that to get the molecular weight of the neutral species. Or if it's a negative ion, you might have to add a proton or get rid of an acetate, again, to find the molecular weight of the compound of interest. Then you divide by the accurate mass or the nominal mass to maybe 3 significant figures. If you want to do an accurate mass, do 4 or 5 to get the whole number, 9 in this case. And then you subtract off the 9 to get the residual, and you multiply it times either the accurate mass or the nominal, depending on what you're doing. And this gives you the residual molecular weight. So you can see somewhat it's just the residual from when you do long division. So I hope you'll find this approach useful in your work. Good day.